Hello and greetings to everyone. We will continue from where we ended last time with the correction of the exercises for application. Question 1 says, which of the following numbers is not in base 5? We have the following numbers. We know in base 5, we make use of the digits 0, 1, 2, 3, and lastly 4. Let's take solution. Knowing base 5, we make use of the following digits. We make use of the digits 0, 1, 2, 3, and lastly 4. We make use of 1, 2, 3, 4, 5 digits. All numbers in base 5 are built using the 5 digits. For the first number A, for A we have the number 213. This number is built up using the digits 2, 1, and 3. The number 213 is in base 5. For B, we have the number 1503. Here we already have a digit which is greater than or equal to 5. Therefore, this number is not in base 5. It's not in base 5. For C, we have the number 4270. 4270. Here we have the digit 7. And in base 5, we don't make use of the digit 7. This number is not in base 5. For D, we have the number 26. 6, the digit 6 is not used in base 5. That means this number is not in base 5. It's not in base 5. For E, we have the digit 5. In base 5, we don't make use of the digit 5. It's not a number in base 5. For F, we have the number 225251. In this number, the digit 5 is being used twice. Therefore, this number is not in base 5. It's not in base 5. The only number which is in base 5 here is the first number, 213. All the other numbers are not in base 5. Question 2 says, change the following numbers to base 10. For E, we have the number 242 in base 5. This will simply be equal to 2. We are going to expand this number in powers of 5. 2 times 5 raised to the power 1, 2, plus 4 times 5 raised to the power 1, plus 2 times 5 raised to the power 0. This will give us 2 times 5 times 5 plus 4 times 5. 5 to the power 1 is 5, plus 2 times 5 to the power 0 is 1. This will give us 2 times 5, then 10 times 5 gives us 50, plus 4 times 5 gives us 20, plus 2 times 1, which gives us 2. 50 plus 20 gives us 70. 70 plus 2 gives us 72. For B, we have the number 1432 in base 5. This will simply be equal to 1 times 5 raised to the power 1 to 3 plus 4 times 5 raised to the power 2 plus 3 times 5 raised to the power 1 plus 2 times 5 raised to the power 0. This will simply be equal to 1 times 5 times 5 times 5 plus 4 times 5 times 5 for 5 squared plus 3 times 5. 5 to the power 1 is simply 5 plus 2 times 5 to the power 0 is 1. This will simply be equal to, 5 times 1 times 5 is 5 times 5 25. 25 times 5 gives us 125 plus 4 times 5 gives us 20. 20 times 5 gives us 100 plus 3 times 5 gives us 15 plus 2 times 1 gives us 2. Next we have to add 125 plus 100 gives us 225. 225 plus 15 gives us 5 plus 5 gives us 10. We write down 0, we carry 1. 2 plus 1, 3 plus 1, we carry 4. Bring down 2, gives us 240 plus 2 gives us 242 in base 10. Next, we have to change the number. So C, we have the number 1450 base 6. We have to change this number to base 10. This will simply be equal to 1 times 6 raised to the power 1, 2, 3 plus 4 times 6 raised to the power 2 plus 5 times 6 raised to the power 1. The last digit is 0, so we are going to ignore it. This will give us 1 times 6 to the power 3 is 6 times 6 times 6 plus 4 times 6 times 6 for 6 squared plus 5 times 6. 6 raised to the power 1 simply gives us 6. Next, this will simply be equal to 1 times 6 remains 6. 6 times 6 gives us 36. 36 times 6 gives us 216 plus, next, 4 times 6 gives us 24. 24 times 6 gives us 144 plus 5 times 6 gives us 30. Next we have to add 144 plus 30 gives us 174. 174 plus 216 gives us 390. Next we go to D, question D. For D we have the number 7402 in base 8. This will simply be equal to 7 times 8 raised to the power 1, 2, 3 plus 4 times 8 raised to the power 1, 2 plus, the next digit is 0, we are going to ignore it, plus 2 times 8 raised to the power 0. This will simply give us 7 times 8 raised to the power 3 is simply 8 times 8 times 8. Multiply 8 by itself 3 times plus 4 times 8 squared is simply 8 times 8 plus 2 times 8 to the power 0 is simply 1. This will simply give us 7 times 8 is equal to 56. 56 times 8 is equal to 448. 448 times 8 is equal to 3,584 plus 4. 4 times 8 gives us 32. 32 times 8 gives us 256 plus 2 times 1, which remains 2. This will simply be equal to, if you take 3,584 84 plus 256. It gives us 3,840 plus 2. It gives us 3,842. We are done with the convention. Next, we go now to the next set of questions. We have question 3, which says change the following numbers from base 10 to the stated base. For the first one, here we have the number 256. We have to change this number to base 5. 256. Here we have the number 256 to base 5. We are going to make use of repeated division. This will give us we have 5, 256, and a column for the remainder. Next, we have to divide 256 by 5. You know, if you take 250 by 5, this will simply give us 5 will go 5 times. We bring out this 050. You know, 250 plus 5 will give us 255. So 5 will go here 51 times. Remainder 1. We bring down 5. 51 divided by 5 will give us 10. Remainder 1. Bring down 5. 10 divided by 5 gives us 2. Remainder 0. Bring down 5. 2 is less than 5. If we divide 2 by 5, the whole number part will be 0 and the remainder will be 2. Copy from bottom to top. Therefore, 256 in base 5 will simply be equal to 2011 in base 5. We must put the base. We now to the next one. The next one we have to change the number 931 to base 6. 931 will be 931 to base 6. First thing, we are going to draw the first column. For the first column, we are going to write down 6. For the next, 931. And for the last column, we have the remainder. Next, if we take 931, we need to divide 931 by 6. Divide 931 by 6, it gives us a whole number part of 155. 155 and a remainder of 1. Next, we have to divide 155 by 6. This will simply give us a whole number part of 25. Let's get the remainder. I take 25 times 6. This will give us 150. 155 minus 150 gives us 5. We bring down 6. We divide 25 by 6. The whole number part will simply be 4. And the remainder will be 1. We bring down 6. 4 is less than 6. So if we divide 4 by 6, the whole number part will simply be 0 and the remainder will be 4. We copy from bottom to top. Therefore, the number 931 in base 6 is simply 4 1, 5, 1. Then we must write down the base in base 6. For C, we have the number 777 to base 7. To convert this number to base 7, we're going to make use of repeated division. Write the number 777, and we need a column for the remainder. If we divide 777 by 7, it gives us 111, and the remainder is 0. We bring down 7. Next, we divide 111 by 7. The whole number part will simply be 15. Let's get the remainder. 15 times 7 gives us 105. 105. If we take 111 minus 105, the remainder will simply be 6. Next, we bring down 7. 15 divided by 7, the whole number part will simply just be 2. Since we know 7 times 2 gives us 14, and the remainder of 1. We bring down 7. 2 is less than 7. If we divide 2 by 7, the whole number part will be 0, and the remainder will be 2. Copy from bottom to top. Therefore, the number 777 in base 7 is simply equal to 2, 1, 6, 0. Then we must write down the base in base 7. Next, now we go to the next question. Question Z, we have the number 890 to base 8. We have to convert this number to base 8. 890. Next, we have the remainder. If you divide the number 890 by 8, the whole number part will simply be 111. Next, for us to get the remainder, we are simply going to multiply 111 by 8, which gives us 888. Next, we are going to subtract 888 from 890, which gives us the remainder of 2. Next, we have to divide the number 111 by 8. The whole number part is simply 13. Next, we need to get the remainder. Take 8 times 13 gives us 104. For us to get the remainder, we are simply going to take 111 minus 104, which gives us 7. We bring down 8. 13 divided by 8 gives us a whole number part of 1. Next, we need the remainder. For us to get the remainder, we are simply going to take 13 minus 8. 13 minus 8 gives us 5. Bring down 8. 1 divided by 8 will give us a whole number part of 0 and a remainder of 1 that we copy from bottom to top. Therefore, the number 890 in base 8 is simply equal to 1, 5, 7, 2 in base 8. We must write down the base, and we are done. Next thing we are going to treat now is changing from one base to another. How we can change, for example, a number which has been given in base 2, we can change it to a new base of base 4 or base 5. Changing from one base to another base. Let's write this down. To change a number, change a number from one base to another base different from the base 10 we first convert the number to, that means we convert the number from the given base to, first convert the number to base 10. Means we first convert the number to become a binary or a decimal number, base 10, by expansion of the number in powers of its base. Stop. And then we convert the result bracket decimal number that means the result is in base 10 to the required base using the method of repeated division. Let's take an example on this. The example will carry everything we have just written above. Example: change. Question E, we have the number 421 in base 5 to base 4. B, we have the number 100011 in base 2 to base 3. Take down solution. For the first one, E, we have the number 421 in base 5. We have to convert this number to base 4. First thing we need to do is we need to start by converting the number 421 in base 5 to base 10. Convert 421 in base 5 to base 10. Let's do the convention. 421 in base 5. First converting base 10. We are going to expand this number in powers of the base 5. This will give us 4 times 5 raised to the power 1, 2, plus 2 times 5 raised to the power 1, plus 1 times 5 raised to the power 0. This will give us 4 times 5 times 5 plus 2 times 5, 5 raised to the power 1 remains 5, plus 1 times 5 raised to the power 0 is 1. This will give us 4 times 5, which is 20. 20 times 5 gives us 100, plus 2 times 5 gives us 10, plus 1 times 1, 1. This will give us 100 plus 10 gives us 110. 110 plus 1 gives us 111. Next thing we have to do is we have to convert 111 to base. We have to convert 111 to base 4. We are going to make use of repeated division. Next thing we convert 111 to base 4. We are going to make use of repeated division. The first column we have 4. The second we have the number 111. And the third we have the remainder. Next we have to divide 111 by 4. The whole number part is simply 27. Next we need to get the remainder. Take 27 times 4 gives us 108. 111 minus 108 gives us 3. Bring down 4. Next we divide 27 by 4. The whole number part is simply 6. And the remainder is simply 3 again. Bring down 4. 6 divided by 4 gives us the whole number part of 1 and a remainder of 2. Bring down 4. 1 divided by 4 gives us a whole number part of 0 and a remainder of 1. We copy from bottom to top. Therefore, the number 111 in base 4 is simply 1, 2, 3, 3. We must indicate the base 4. Now we need to conclude. For our conclusion, therefore, the number 421 in base 5, 421 base 5 in base 4 is simply equal to 1, 2, 3, 3 in base 4. Must indicate the base. Next, we answer the next question for B. B, we have the number 1, 0, 0, 0, 1, 1 base 2. We have to convert this number to base 3. Now, first step, we need to convert this binary number 1, 0, 0, 1, 1 base 2 to base 10. And for us to perform this conversion, we need to write the number in expanded form. Then we simplify 1, 0, 0, 0, 1, 1 is 2 simply equal to 1 times 2 raised to the power 1, 2, 3, 4, 5 plus the next digits are 0, 0, so we are going to ignore them. We move now to 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. This will simply be equal to 1 times 2 times 2 times 2 times 2 times 2. We are going to multiply the number 2 by itself 5 times 1, 2, 3, 4, 5 plus 1 times 2 raised to the power 1 is simply 2 plus 1 times 2 raised to the power 0 is 1. This will simply give us 1 times 2 remains 2 times 2 4 times 2 8 times 2 16 times 2 32 plus 1 times 2 2 plus 1 times 1 1. This will give us 32 plus 2, which is 34. 34 plus 1 gives us 35. Next, we have to convert 35 to base 3. Convert 35 to base 3. Let's do the convention. We are going to make use of our method of repeated division. First 3 in the first column. In the next column we have 35. And in the last column we have the remainders. We divide 35 by 3. The whole number part will simply be 11. And the remainder will be 2. We bring down 3. 11 divided by 3 gives us a whole number part of 3 and a remainder of 2. Next we bring down 3. 3 divided by 3 gives us a whole number part of 1 and a remainder of 0. We bring down 3. 1 divided by 3 gives us a whole number part of 0 and a remainder of 1. Then we copy from bottom to top. 35 in base 3 is simply equal to 1, 0, 2, 2. We must write down the base, which is 3. We conclude, therefore, the binary number 1, 0, 0, 0, 1, 1 in base 1, 1 base 2 is simply equal to 1, 0, 2, 2 in base 3. Then we underline the answer and we are done. Next, now we are going to take the exercise for application on this. Exercise. So, application. Goes as such. Change the following. Change the following. For A, we have 1, 0, 0, 1 0 1. It's a binary number. We have to change this number to base 4. For B, we have the number 1 1 1 1 1 0. Binary number, we have to change it to base 5. For the next C, we have the number 1 0 0 2 in base 3. We have to change this number to base 2. D, we have the number 6 4 3 in base 7. We have to change this number to base to a new base 6. Next, we have the number 1 5 8 in base 9. We have to change it to a new base of 3. These are the exercises we have. Next, we are going to treat arithmetic on number bases. That means how to add number bases, how to subtract them, how to multiply, and how to divide them. Thank you very much for watching this video. Share, like the video, and subscribe to this channel.